This is the Edexcel higher tier, paper 3 calculator paper from November 2019. Question 1 says expand and simplify x plus 5 times x minus 9. So we're multiplying the first term in the first bracket by both of the terms in the second bracket, and the second term in the first bracket by both the terms in the second bracket. So x times x will give us an x squared. X times negative 9 gives us a minus 9x. 5 times x is 5x. And 5 times negative 9 is negative 45. So collecting the like terms, simplifying this, we've got minus 9x plus 5x. So negative 9 up 5 is negative 4. So our final answer, x squared minus 4x minus 45. Part B says factorize fully. When it says factorize fully, it means we need to take out everything we possibly can from our expression. There can't be left anything that will factorize. So we've got 6 and 9. They're both in the 3 times table. So we take 3 outside. And we've got x squared and x. We can take x out of both of those. So 3x on the outside. Then what's left? 3x times what makes 9x squared. 3x times 3x will make 9x squared. And 3x times what makes 6x? That's a positive 2. Question 2a. Use your calculator to work out 29 squared minus 4.6 all over the square root of 35 minus 1.9 cubed. So we're just going to type it into the calculator exactly how it looks here. So it's going to look exactly the same. So fraction button first. Then we're just going to type in 29 squared minus 4.6 on the top. Click down, and then the square root button. 35 minus 1.9 cubed. Press equals, and there's our answer. The question says write down all the figures on your calculator display. So 157.668255. 157.668255. Part B, write your answer in part A, correct to 4 significant figures. So 1, 2, 3, 4. The next number is a 6. It is 5 or above. So we round up to 157.7. Question 3. The scatter graph shows information about the marks a group of students got in a science test and in a maths test. So a scatter graph has been drawn here. And we're told Jamie got 34 in science. Use the scatter graph to find an estimate for Jamie's mark in maths. To do this, to use a scatter graph to make an estimate, we need to draw a line of best fit. A line of best fit is the line that best fits the points. So we're trying to minimize the distance from the points to the line. So we should have roughly the same number of points on each side. So if we have a line that looks like this, something like this, we're going to have 6 points on both sides. Trying to minimize the distance. So maybe over here somewhere. Something like that. So somewhere around there will be a good line of best fit. So now we're going to use it. Jamie got 34 in science. So we go to science, which is the x-axis, and 34, up to the line, and then along, and we read off our answer. There'll be a range of acceptable answers. So I'm getting 39. So I'm going to put 39 as my answer. But somewhere near 39 will be an acceptable answer. So you're using your line of best fit. And as long as your line of best fit fits the points, you should be okay. Question 4. The table gives information about the times taken in seconds by 18 students to run a race. So we've got grouped data here. We're working out, the question says, work out an estimate for the mean time. So to work out, we can't work out the mean using group data because we don't know these actual times. So we know 8 students took between 20 and 25 seconds, but they could have been 21, 22, 23. We don't know the exact numbers. So as an estimate, we use the midpoint of the group. So we're going to say one student took 7.5 seconds. We've got 2 lots of 12.5 seconds. 7 students taking 17.5 seconds. And 8 students taking 22.5 seconds. It's just an estimate. It can't be accurate because we don't know what these actual times are. So now we need to, well, to find the mean, we add up all the numbers and divide by how many. To add up all the numbers, we're going to multiply across. 1 7.5 adds up to 7.5. 2 12.5s make 25. 7 17.5s is 122.5. And 8 22.5s makes 180. So to add them all up, we're adding down now. So 7.5 plus 25 plus 122.5 plus 180 gives us 335. So that's the total. That's 7.5 plus 12.5 plus 12.5 plus 17.5 plus 17.5 7 times plus 22.5 plus 22.5 and so on. So they all add up to 335. There are 18 students. So the mean, or the estimate for the mean, 335 divided by 18. And I've got 18.61 recurring, 18.61111 and so on. We want our answer to 3 significant figures, so 18.6. Question 5. Write 37 centimeters cubed in millimeters cubed. So each 1 centimeter cubed, which is 1 centimeter by 1 centimeter by 1 centimeter, a cube with a length, width and depth of 1 centimeter is the same as a cube with a length, width and depth of 10 millimeters. So in every 1 centimeter cubed, you can fit 10 millimeter cubes across, 10 millimeter cubes back, and 10 millimeter cubes up. So in each 1 centimeter cube, you can fit 10 times 10 times 10. So 1 centimeter cubed is the same as 1,000 millimeters cubed. In each centimeter cubed, you can fit 10 across, 10 back, so 100, times 10 up, 1,000. So 1 centimeter cubed is the same as 1,000 millimeters cubed. If we've got 37 centimeter cubes, that means we've got 37,000 millimeters cubed. So 37,000. Question 6. Nima was driving to a hotel. He looked at his sat-nav at 13:30. So distance to destination 65 miles. Nima arrived at the hotel at 14:48. Work out the average speed of the car from 13:30 to 14:48. So speed is distance divided by time. We know the distance is 65 miles. And the time is however long it takes to get from 13:30 to 14:48. So that's 1 hour to 14:40 to 14:30 even. So 1 hour and then another 18 minutes. So 1 hour and 18 minutes. But we need that to be written in hours. So we can't have 1 hour and 18 minutes. We need that in hours. So 18 minutes is the same as 18/60ths of an hour. So in an hour there are 60 minutes. So 18 minutes is 18/60ths. So 1 hour plus 18/60ths. And that's 1.3 hours. So that's 1.3 hours. So our distance is 65 over our time, which is 1.3. 65 over 1.3 is 50. So it's 50 miles per hour. We can also use the time button on the calculator. So 65 divided by 1 hour 18 minutes is 50. Or we could have also worked out this time difference using the time button. So we could have done 14 hours, 48 minutes, take away 13 hours and 30 minutes, and that would have told us it's 1 hour 18, and then we could have just done 65 over the answer and got 50 as our answer, so 50 miles per hour. Question 7. Write 32,460,000 in standard form. So standard form, we need to write a number between 1 and 10. So that's going to be 3.246. And then times 10 to a power. So how many times do we have to multiply 3.246 by 10 to get 32,460,000? So 1, 2, 3, 4, 5, 6, 7. So 7 times. And we can check that using our calculator by typing our answer, 3.246 times 10 to the power of 7, into the calculator, and we'll go back to 32,460,000. Part B, write 4.96 times 10 to the power of negative 3 as an ordinary number. So when we've got a negative power, that means we're dividing by 10. So it's 4.96 divided by 10 3 times. So that's 0.00496. I've got 3 zeros here and power's negative 3. And again, check the answer by typing the answer into the calculator, and we get 4.96 times 10 to the power of negative 3. Asma was asked to compare the following two numbers. So A is 6.212 times 10 to the power of 8, and B is 4.73 times 10 to the power of 9. She says 6.212 is bigger than 4.73, so A is bigger than B. Is asthma correct? You must give a reason for your answer. So no, asthma is not correct because B's got a bigger power of 10. So no, and our reason is B has a bigger power of 10, so it's actually a bigger number. B is billions, so 4.73 billion. And A is 100 millions, so 621.2 100 million. Or we could just write them out as ordinary numbers and have 6212 and then 5 zeros and 473 and then 7 zeros, and we can see that B is actually bigger. Or another way, we could say if we multiply our number on the front by 10 once, B would be 47.3 times 10 to the power of 8. So now they're both powers of 8, so we can compare them, and 47.3 is bigger than 6.212. So any of these reasons will work. So which one should I write? So 47.3 times 10 to the power of 8 is bigger than 6.212 times 10 to the power of 8. Question 8. The diagram shows a regular pentagon and a parallelogram. Work out the size of angle X. You must show all your working. So with the parallelogram, parallelograms have, well, two equal angles. The opposite ones are equal. And the other angles are also equal. And we can use co-interior angles. So these two angles that make a C shape add up to 180 degrees. So 180 take away 117 is 63. So this angle here is 63 degrees, as is this one here. Now for the regular pentagon, we can use exterior angles. So exterior angles always add up to 360 degrees. So 360 divided by 1, 2, 3, 4, 5 angles in a pentagon. So 360 over 5 is 72. So this angle here is 72 degrees. And then we can use angles on a straight line. So angles on a straight line have to add up to 180. So 180, take away the 72 and take away the 63. Is 45 degrees. So X equals 45 degrees. Question 9. Enlarge triangle A by a scale factor 2.5, center 0, 1. 0, 1. It's been marked on for us. So the scale factor is 2.5, which means to get to any point, we're going to go 2.5 times as far. So to go from our center to this red point, we're going along 1 at the moment. So 1 times 2.5 is 2.5. So 1, 2.5. So that point moves to there. To get to this green point, we go along 1, up 2 at the moment. And if we times that by 2.5, we're going to go along 2.5, up 2 2.5s of 5. So along 2.5 and up 5. 1, 2, 3, 4, 5. And to get to this blue point, we go along 2, up 2 at the moment. So 2, 2 at the moment, times it by 2.5. So that'll be along 5, up 5. So 1, 2, 3, 4, 5, and then up 5. 1, 2, 3, 4, 5. So then we can just join up these points. And we can check the lengths. So it was 1 along, now it's 2.5 along. It was 2 down, so now it's 5 up. So we know we've got the right shape. And we can also check, if we wanted to, that all the points line up. So the green points line up when you hold when you draw a line from the center of enlargement. The blue points join up and the red points join up. Question 10a. Solve 9 plus x divided by 7 equals 11 minus x. So the first thing we want to do is get rid of this divided by 7. So to get rid of a divide by 7, we do the opposite, which is multiplying by 7. So let's times both sides by 7. And that will give us 9 plus x equals, well, 7 times 11 minus x. Expanding the bracket, so 9 plus x equals 77 minus 7x. I want the x to be positive, so I'm going to plus 7x to both sides. So I've got 9 plus x, 1x plus 7x is 8x equals 77. I want x by itself, so I'm going to get rid of the 9. Take 9 away from both sides. 8x is 77 minus 9, which is going to be 68. And then divide both sides by, so 77 minus 9 was 68. And then divide both sides by 8, which is 8.5. So x is 8.5. Part B, simplify. So I've got 4 times y plus 3 to the cubed on top over y plus 3 squared on the bottom. So we can just cancel off. So this is the same as 4 times y plus 3 times y plus 3 times y plus 3 over y plus 3 times y plus 3. So as long as you divide or times top and bottom by the same thing, you can change a fraction. So if we divide top and bottom by y plus 3 and then divide by y plus 3 again, we're just left with 4 times y plus 3. Question 11. The probability tree diagram shows the probabilities that Bisma will be late for work on 2 days next week. We need to calculate the probability that Bisma will be late on exactly one of the 2 days. So we want either late and then not late, or we want not late and then late. We don't want late late or not late, because we only want Bisma to be late once. So when we're working out a probability from a tree diagram, when we go across the branches, we times. So the probability of late then not late is 0.07 times 0.98. So 0.07 times 0.98, 0.07 times 0.98 is 0.0686. I'm just going to store that in the calculator because I'm going to use that in a second. And the probability of not late and late is 0.93 times 0.11. Which is 0.1023. So then with these two options that give me one late, I'm going to add them together to give the final answer. So 0.0686 plus 0.1023. So my last answer plus my first answer is 0.1709. Question 12. The stem and leaf diagram shows information about the heights in centimeters of 23 sunflowers. On the grid, draw a box plot for this information. So to draw a box plot, I need to know the minimum, the lowest one. So the lowest is 173. The highest is 219. I need to know the median. The median's the middle number. There are 23 sunflowers, which means I'm going to cross off 11 on both sides to leave one in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And going backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that leaves a median of 197. I need to find the lower quartile and the upper quartile as well. So the lower quartile is like the median for the lower half. It's 25% of the way through the data. So again, for the lower half, I'm going to cross off on both sides. There were 11 on each side, so it's going to be 5, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So the lower quartile is 188. And again, for the upper quartile, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The upper quartile is at 209. So now they're all the lines to draw on the box plot, and I just need to draw them on now. So the lowest at 173. Lower quartile at 188. Median at 197. Upper quartile at 209. And the highest was at 219. So then we draw lines from the upper quartile to the end and lower quartile to the end, and a box around the middle 50%. So there is our box plot. So just check these numbers: 173, 188, 197, 209, and 219. That's what we wanted. So there's our box plot. Question 13. Liquid A and liquid B are mixed together in the ratio 2 to 13 by volume to make liquid C. Liquid A has a density of 1.21 grams per centimeter cubed. Liquid B has a density of 1.02 grams per centimeter cubed. A cylindrical container is filled completely with liquid C. The cylinder has a radius of 3 and a height of 25. So we can use this volume for the total volume of liquid C and then share that in the ratio. So we've got the volume of A and B, and then we're going to work out the mass. So that can be the mass of A plus the mass of B. So let's start with the volume of this cylinder. So it's the area of the base times the height. So the volume, the area of a circle is pi times the radius squared, and then times the height. So it's going to be pi times 3 squared times 25. So pi times 3 squared times 25 gives us 225 pi. And that is in centimeters cubed. So now we're going to share that in the ratio 2 to 13. So 2 parts and 13 parts mean we've got 15 parts. And actually we can just say it's 2/15 and 13/15. That will make it easier. So 2/15 of, so liquid A has a volume of 2/15 of 225 pi. I'm just going to store 225 pi as A. So I want 2/15 of A. 2/15 of A is 30 pi. So liquid A's volume is 30 pi centimeters cubed. And for liquid B, it's 13/15 of 225 pi. Which is 195 pi centimeters cubed. So there we've got a volume and a density for B and a volume and density for A. So we're going to use density equals mass over volume. Density equals mass over volume. So to find the mass, we're going to be doing density times volume. So mass is density times volume. So for A, mass is density 1.21 times volume 30 pi. 1.21 times 30 pi is 114. Give your answer 3 significant figures. Let's do 114.04. And that's grams. And for B, the mass is density 1.02 times volume 195 pi. Actually, I'll store this as A. And then 1.02 times 195 pi, which is 624.86. So we want the total mass, which are these two answers added together. So add them up, and we get 739 to 3 significant figures. Question 14. A group of people went to a restaurant. Each person chose one starter and one main course. So the starters, we can either have soup or prawns, and for the main course, lasagna or curry. So the number of people who chose soup to the number of people who chose prawns is 2 to 3. Of those who chose soup, we've got lasagna to curry. Of that who chose prawns, we've got lasagna to curry. So what fraction chose curry? So we can either have soup and curry or prawns curry. So they're the two options we're looking for. So we want what fraction of soup curry, what fraction of prawns curry, and we'll add them together. I'm going to convert all these into fractions to do this. So soup to prawns is 2 to 3. So that means we've got 2/5. There's 5 parts, so 2/5 soup and 3/5 prawns. 2/5 soup, 3/5 prawns. Of those who chose soup, we've got 5 to 3. So it's 8 parts, so 5/8 and 3/8. And of those who chose prawns, we've got a ratio of 1 to 5. So there's 6 parts, 1/6 and 5/6. So soup then curry is 2/5. Then of those who chose soup, curry is 3/8. And prawns was 3/5. And of those who chose prawns, curry is 5/6. So the probability, or the fraction, that chose soup and curry is 2/5 times 3/8. 2/5 times 3/8. And that's 3/20. And prawns and curry is 3/5 times 5/6, which is a half. So add these two together, gives us 13/20. If this was a bit confusing, we could have used a tree diagram here as well. So we could have used a tree diagram, and we could have said soup, prawns, curry, lasagna, curry, lasagna, and we could have written the probabilities in. So it was 2/5, 3/5, and soup curry was 3/8, 5/8, and prawns curry was 5/6 and 1/6. So we could have used this tree diagram, and we would have had soup curry or prawns curry. They would have been our options. Either way, we're ending up with this answer of 13/20. Question 15. Prove algebraically the sum, so added, of the squares of any two consecutive even numbers is always a multiple of 4. So our first even number, an even number can be written as 2n, so anything in the 2 times table. The next even number is 2 after the first one, so 2n plus 2. If our first even number's 4, the next one's 6. If our first one's 10, the next one's 12. So 2 consecutive even numbers, one is 2 more than the other one. So it's the sum of the squares. So let's expand and simplify this, and we should be able to show it's a multiple, or prove it's a multiple, of 4. So 2n squared means 2n times 2n. 2 times 2 is 4, n times n is n squared. And 2n plus 2 squared, we can think of this as double brackets. So we've got 2n times 2n, 4n squared. 2n times 2 is 4n. 2 times 2n is 4n. 2 times 2 is 4. So simplifying, we've got 8n squared plus 8n plus 4. So we can show it's a multiple of 4 by factorizing out to 4. So if we take 4 outside, we've got 4 times 2n squared plus 2n plus 1. So it's a multiple of 4. Question 16. Y is inversely proportional to the square of x. So inversely proportional means y is k over the square of x, so x squared. So y is inversely proportional to the square of x. And then we're told when y is 8, x is 2.5. So we can find out what this k number is. We can find out what this k is. So 8 equals k over 2.5 squared. So k is 8. If we multiply both sides by 2.5 squared, k is 8 times 2.5 squared, which is 50. So k is 50. So our formula is y equals 50 over x squared. Find the negative value of x when y is 8/9. So we're going to change y into 8/9. So 8/9 is 50 over x squared. We want to get rid of these fractions. So let's multiply both sides by x squared and multiply both sides by 9 at the same time. So that will get rid of the fractions. So 8x squared equals 50 times 9, which is 450. We want x squared by itself, so divide both sides by 8, which is 225 over 4. And then square root both sides. But remember, the question said find the negative value of x. And when we square root, we have plus or minus. So plus or minus the square root of 225 over 4. The square root of 225 over 4 is 7.5. So x is plus or minus 7.5. We want the negative answer, so minus 7.5. Question 17. Here is the graph of y equals x squared minus 3. So we've got a graph drawn for us. Use the graph to find estimates for the solutions to the equation x squared minus 2x minus 2 equals 0. So we've got the graph of y equals x squared minus 3. And we need to find estimates to this different equation. So what we can do is we can make this x squared minus 3 equal something. So we've got x squared minus 2x minus 2 equals 0. So let's plus 2x to both sides. X squared minus 2 equals 2x. And then take 1 away from both sides. So x squared minus 3 is equal to 2x minus 1. So what we can do is use the fact that the solutions to simultaneous equations are where two graphs intersect. So that if we have the graph of y equals x squared minus 3, which is what we've already got, and the graph of y equals 2x minus 1, the intersection of those two graphs will be where x squared minus 3 is equal to 2x minus 1. So we've got one of the graphs drawn already. We need to draw the other one. So we're drawing y equals 2x minus 1. So it's got a y-intercept of -1, which is here. And when it goes up in 2's, it's got a gradient of 2. So for every 1 we go across, we go up 2. For every 1 we go across, we go up 2. 1 across, up 2. So we're going to have a graph that goes like this through all of these points. And we need to know where they intersect. So the intersections of these graphs, we're looking at this point and this point. So what are the x coordinates for these two intersections? We've got minus 0.7 and (2.7) and 2.7. Question 18. The diagram shows triangle ABC, and we've got all this information. AB is 3.4, AC, BC, all shown on the diagram. D is the point on BC. D is the point on BC, such that the size of angle DAC is 2/5 the size of angle BCA. So if BCA is X, BCA, let's call that X. DAC is 2/5 of that. DAC is 2/5 of X. Calculate the length D to C, this one here, and give your answer correct to 3 significant figures. So this length D to C is what we're working out. So we can use the cosine rule for the big triangle ABC to find this angle X, and then we'll also know 2/5 of X and all 3 angles in this second triangle ACD, and then we could use the sine rule to find this length. So let's firstly use the cosine rule to find X. So our triangle is going to be it's triangle ACB. We've got 3.4, 6.2 and 6.1, and we want to know this angle here. So we're going to use cosine rule for angles. So we can use cos A is equal to B squared plus C squared minus A squared over 2BC. So if this is big A, the angle is big A, the one opposite it is little a, and the other two, either way round, are B and C. So let's substitute these in now, and we will get our angle. So 6.1 squared plus 6.2 squared minus 3.4 squared over 2 times 6.1 times 6.2, and that'll be cos A. So that'll be cos A (6.1 squared plus 6.2 squared minus 3.4 squared over 2 times 6.1 times 6.2. So that's cos A, And to get A by itself, we shift cos the answer, and we've got 32.08. So A is shift cos of that, which is 32.08. So X is 32.08. This angle here is 2/5 of that. So let's store 32.08 as C. So we'll store that as C. And 2/5 of that answer is 12.83. So this is 12.83, which we'll store as A. Store that one as A. And then for angle D, we're 180, take away A and take away C, which is 135.09. I'll save that one as D. So now we can use the sine rule. So we want opposites. So we're going to use the two lengths, the length we're trying to work out, and its opposite, and the other length we know, the 6.2, and its opposite. So we've got X over sine 12.83. Equals 6.2 over sine 135.09. And 12.83 we saved as A, and 135.09 we saved as D. So if we want X by itself, we need to multiply both sides by sine 12.83. So in the calculator, this is what we want to type. So we've got 6.2 over sine D times sine A. And we've got 1.95 centimeters. And I'll just check that with the numbers we used, just to check I haven't saved something wrong. We should get an answer roughly the same. 1.95. Question 19. The graph shows information about part of a cyclist's journey. So we've got distance covered in meters and time in seconds. Work out an estimate for the speed at time 6 seconds. So for a distance time graph, the speed is the gradient. So we want the gradient when the time is 6. So the gradient here, and we're going to draw a tangent. We're going to draw a tangent at that point. So I'm going to draw a line and try and move it into place. A tangent. So we want just to touch the graph at time is 6. So somewhere around there. A tangent at time 6 seconds. So there's a tangent. We just need to work out the gradient of it now. So let's find some points. Some good points, hopefully. So up here, I've got 8 and 16, 17. 8, 17. And down here, I've got 4 1, 2, 3, 4, 3. So the gradient is the change in y over the change in x. We can use the formula y2 minus y1 over x2 minus x1, the change in y over the change in x. So x1, y1, x2, y2. So it's going to be 17 take away 3 divided by 8 take away 4. 17 take away 3 divided by 8 take away 4. And I've got 7 over 2, or 3.5. So we've got 3.5 meters per second. Question 20. Here are the first 5 terms of a sequence. -1, 0, 3, 8, 15. Find an expression in terms of n for the nth term of this sequence. This is a quadratic sequence. And we can tell that because the second difference will be the same. So the first difference from -1 to 0 is 1. From 0 to 3 is 3. From 3 to 8 is 5. From 8 to 15 is 7. And the second difference is 2, 2, 2. So it's a quadratic sequence. And that's going to be in the form something n squared plus something n plus c. I'm going to use the fact that I know that this number here, the second difference, is 2a. So 2 times the coefficient of n squared. This difference between the first and second terms is 3a plus a b. And this -1 is a plus b plus c. So 2a equals 2. We can solve these equations now. 2a equals 2. Half both sides. A must be 1. 3a plus b equals 1. So 3 1s plus b is equal to 1. 3 plus b is 1. Take away 3 from both sides. 1 take away 3 is -2. And a plus b plus c is -1. So we've got 1 minus 2 plus c is -1. -1 plus c is -1. Add 1 to both sides. C is nothing. So we've got 1n squared minus 2n's plus nothing. So n squared minus 2n. And we can check that. So n squared minus 2n. If we substitute 1, 2, 3, 4, 5 in, we should get 15. If we substitute 4 in, we'll get 8, or 3 in, we'll get 3. So let's make sure we get 8 as well. So we know we've got the right nth term. Question 21. When a biased coin is thrown 4 times, the probability of getting 4 heads is 16 over 81. Work out the probability of getting 4 tails when the coin is thrown 4 times. So it's heads, then heads, then heads, then heads to get this probability. So it's the probability of heads times the probability of heads times the probability of heads times the probability of heads is 16 over 81. So that's the probability of heads to the power of 4 is 16 over 81. If we want to find the probability of getting a head, we have to do the fourth root of 16 over 81. And that will be 2/3. The fourth root of 16 is 2. 2 times 2 times 2 times 2. And the fourth root of 81 is 3. 3 times 3 times 3 times 3. So if the probability of heads is 2/3, the probability of tails must be 1/3. So what's the probability of getting tails 4 times in a row? So 1/3 times 1/3 times 1/3 times 1/3, which is going to be 1 on top, and on the bottom 3 to the power of 4 again is 81. Of course you can use a calculator, so it's 1/3 to the power of 4 is 1/81. Question 22. Show that 7x minus 14. So straight away I can see that this factorizes over x squared plus 4x minus 12 divided by x minus 6 over x cubed minus 36x simplifies to ax. So simplifies just down to ax, where a is an integer. So when we divide by a fraction, we can change it to a times and flip over the second fraction. So we'll do that. So I'm going to have, we may as well start factorizing as well. So for each of these that we can, we'll factorize. So for this 7x minus 14, we'll take 7 outside the bracket. 7 times x makes 7x. 7 times -2 is -14. And that's over, we've got a quadratic, so an x in both brackets. What multiplies to make -12 and adds to make a +4? That's a 6 plus 6 minus 2. And then that's times, we've got x cubed minus 36x. So firstly, we can take an x out of it. So I've flipped it so the bottoms become the top, the tops become the bottom. So if we take an x out, we've got x squared minus 36 left. And that factorizes as well. That's the difference of 2 squares. So we can change that into x plus 6 and x minus 6, or x plus 6 times x minus 6. Let's do this cancelling. No, we won't. Let's finish factorizing first. So 7 times x minus 2 over x plus 6 times x minus 2 times x plus 6 times x minus 6 over x minus 6. So we're timesing fractions. We do that by timesing the top and timesing the bottom. So let's do 7 times x for the 7x, and then we've got x minus 2 times x plus 6 times x minus 6 on the top, and on the bottom x plus 6 times x minus 2 times x minus 6, and we can see that we've got x minus 2. We can divide top and bottom by x minus 2. We can divide top and bottom by x plus 6. And we can divide top and bottom by x minus 6. And that leaves us with just 7x, which is what we wanted. Question 23. The diagram shows sector OACB of a circle with center O. The point C is the midpoint of the arc AB. The diagram also shows a hollow cone with vertex O, and the cone is formed by joining OA and OB. So this sector gets folded to make this cone. So the sector is folded, it makes the cone. The cone has a volume of 56.8 centimeters cubed and a height of 3.6. and we need to calculate the size of angle AOB of sector OACB. So we're calculating this big angle here. So that's, I'll call that theta. So we're calculating that angle. We're told information about the cone, and we've got the volume of a cone and the curved surface area of a cone formulas, which is a clue as to what we will be using. So we're going to start with the volume of a cone, and we need to find the surface area. So we're going to use the volume of a cone to find the radius of the cone, and then we'll use that to find the surface area of the cone, and then that will become the surface area of the, not the surface area, the area of the sector, which we can use to find the angle. So one step at a time, let's deal with the volume of a cone. So the volume of a cone is 1/3 pi r squared h. So 1/3 pi r squared h, and that's equal to 56.8. And we're told the h is 3.6, the height is 3.6. So 1/3 times pi r squared times 3.6 equals 56.8. We want to find r here, so let's divide both sides by, so r squared is 56.8 divided by 1/3 pi times 3.6. So we're dividing both sides by 1/3 pi times 3.6. We could have done that in different steps, but we can equally just do it in one go. So 56.8 over 1/3 pi times 3.6. So r squared is 15.06, and so on, 0.66. So r is the square root of that, which is 3.88. And I'm going to store that as a, because we'll probably be using that again in a minute. R is 3.88 centimeters. So that's the radius of this cone. So 3.88 centimeters. We're now going to use the curved surface area. So that's pi times r times L. L is this diagonal, but we don't know yet. So we're going to have to work out L. But we do know the height. That's supposed to be a straight line. We do know the height. So we can use Pythagoras to find L. So the height is 3.6. So a squared plus b squared equals c squared. L squared is 3.6 squared plus 3.88 squared. L is the square root of 3.6 squared plus 3.88 squared. So the square root of answer squared plus 3.6 squared is 5.29, and so on. So 5.29. So this is 5.29. So now we can work out the curved surface area. So curved surface area is pi times r times L. And I'm going to save L as B just so it's there. So it's pi times my last two answers, which is 64.557. 64.557 centimeters squared. So that's the area, the surface area of this cone, which is the same as the area of the sector. So the area of the sector is 64.557 centimeters squared. The radius is O to A. So the radius of the sector is L, which is 5.29. And we can use the area of the sector now to find the angle. So let's find the area of the sector. So area of sector is theta over 360. What fraction of the circle have we got? And that's that fraction of the area of the whole circle, pi r squared. So the area of the sector is 64.557. And that is equal to theta over 360 times pi times the radius, which is 5.29 squared. So just to remember, I've saved 5.29 as b in the calculator, so I can use that as the whole number. So I'm going to divide both sides by pi times b squared. So I'm going to take my answer, divide it by pi times b squared. So answer divided by pi times 5.29, which I've saved as b squared. So that's 0.733. .733 is theta over 360. So 0.733 is theta over 360. So theta is times 360 times both sides by 360, and I've got 264 degrees to three significant figures, 264 degrees. Question 24. OXYZ is a parallelogram. O to X, the whole of O to X is called A, which means Z to Y will also be A, because the opposite sides of a parallelogram are equal. And O to Y, the whole of O to Y, is called B. P is the point on OX, such that O to P to X is 1 to 2. So there are three parts. So O to P is 1/3 of the journey. So 1/3 of A. And P to X is the other 2/3. So 2/3 of A. And R is the point on OY, such that OR to RY is 1 to 3. So there are four parts. So we've got 1/4 of B, and we've got 3/4 of B. Work out in its simplest form the ratio Z to P to Z to R. So we're going to work out how to get from Z to P and how to get from Z to R. So let's go from Z to P. How can we get from Z to P? So we could work out Z to O first, but we may as well just go Z to P is A minus B plus 1/3 of A. So A minus B plus 1/3 of A. A minus B plus 1/3 of A, which is 4/3 of A minus B. And then how about z to r, z to r is a minus 3/4 of b. A minus 3/4 of b. And we want the ratio z to p to z to r. So how do these two relate? How do they relate? So if we can change z to p if we take, well, factorize out 4/3, or should we factorize out 3/4 from z to r? Let's do z to r. So for z to r, let's take 3/4 out of it. So have 3/4 on the outside. 3/4 times what makes a? That's going to have to be 4/3 a. And 3/4 times what makes minus 3/4 b? That's just minus b. So if we expanded this bracket, we'd go back to z to r. So what we can see here is z to r is 3/4 of 4/3 a minus b. So 3/4 of z to p. Z to r is 3/4 of z to p. So this is 3/4 and 1/4 of the whole journey. 3 parts and 1 part, 3 to 1. But what was the question? The ratio z to p to z to r. So z to p is 4 parts, z to r is 3 parts, so it's 4 to 3. So the ratio z to p to z to r is 4 to 3.